now it's good. So, okay. Yeah, that was unplugged hub. So, okay. I think we can start.
All right, thanks, excellent. Okay, so, you're gonna, okay.
Possiamo partire in pizza margherita? Okay. So welcome on this last day for EuroPython. We have today a training session on how to write an application, right, with Python. Right?
Yes.
With Daniel Nouri, which is going to be here for 4 hours, but usually this is a very nice time to perform stuff and hands-on. It's very useful. Thank you very much, Daniel.
Thanks. Okay, so thanks for coming. We're going to write a little pyramid application today. I have a material for you, which you should go and maybe download now. It's available on GitHub. You might either want to git clone it or, download the zip. And the material contains, it's a folder with a couple of example directories. So here you can see we're going to step through 7 examples basically. First we're going to do the installation, then we're going to start with the first example, which is a very simple, actually the Hello World example pretty much from the Pyramid website, the most simple Pyramid application that you can write. Then we're going to talk about the ZODB scaffold, which is, sorry, I should probably, this is the link where you can, in the meantime, get a copy of the tutorial's material. The second example is about the ZODB scaffold. So we're going to work with the ZODB, which is the SOAP object database for this example. The third example is going to be about templating, pyramid and templates. We're going to use chameleon templates in our example. I'm saying we're using this and that in our example because actually we can, Pyramid offers us the possibility to use different technologies. That's why I'm saying we're actually making choices here. So the fourth example is about writing forms, where we're going to, create HTML forms to add, edit, and delete content. In the fifth example, we're going to, and these are all, one is built on top of the other, right? So you can follow along on the example, and once we're done, we're going to go into the next example, but it's going to be the same project, so it's kind of an evolving project until we have a somewhat complete project in the end. So we're going to talk about users in the fifth example, more about users and security in the sixth example, and then the seventh is the final project. And so these are all things where Pyramid gives you a lot of possibilities to configure and set together your applications. That is, you're not getting a out-of-the-box solution. I mean, in that case, it really differs from Django, because Django already makes decisions about what the templates, the templating language, the ORM, or how you're going to persist your data. There is an admin, there is authentication built in out of the box. So when you start a Django project, you already have all of these things available. With Pyramid, it's different because Pyramid is more modular and it's more low level. which means that it's more appropriate for highly customized web applications, whereas Django coming with the admin and the SQL database and all that is more fit for a certain type of web application. With Pyramid, you have more choices. You can mix and match better. So in that way, it's maybe more similar to to Flask or something. Pyramid, that is. Right. So once you have checked out these this folder, you should be able to see something like this. Actually, ignore the bin directory, but you should have a directory structure like this. We're going to spend the first couple of minutes, maybe 10-15 minutes, to get everyone installed. That is, who here doesn't have virtual env on his machine? Just maybe, everyone has virtual env installed? And okay, so you can either use Python 2.6 or 2.7 for this tutorial. They're both going to be fine. And we're also going to need a C compiler. That is because we're going to work, not because Pyramid itself needs a C compiler, but we need it for the ZODB. So I hope that those who have a Mac, they already have Xcode installed or some other C compiler available, because that's pretty much, if you need to install a C compiler on a Mac, I think it might take a while, and then but does anyone not have or doesn't know if they have a C compiler? Or are you all confident that you have one? Okay, great. Yes?
I do have a C compiler, but I also have Windows with
I've actually not tested this tutorial with Windows. Depending on how confident you are with your compiler and your Python tools.
I already built or installed applications that had extensions. So
Right. I hope so. Let's say, should it not work, maybe I can suggest that you team up with someone, or so that you don't spend too much time, and you can follow up on the installation maybe at home, if that's a problem with the installation. So great. So that means that we don't actually need to spend so much time on installation, if I'm correct. Because we actually have a lot of other things going on. But so on Debian or Ubuntu, this is an example of how you could install a C compiler. Apparently everyone has one. On Mac you would need Xcode. We need to get Python 2.7 plus the header files. So that means you need to be able to build you need to have this, that's again for compiling the ZODB. So on Debian or Ubuntu, that would be install the -def package of Python. If you don't have these, you're going to get an error as soon as we're trying to install the ZODB example. I'm actually pretty sure that in a source install of Python you already have this set up, so you don't really need to worry about this. Just on if you're using a package management system and you install Python and they're divided into two packages, you might need to install separately the Python dev package. Okay, so let's just try this out, and we'll see if someone fails and someone needs help or something. Right, so everyone has virtual env installed. What I'm going to do is, so what you should do now is, now that you have this folder, hopefully, were you able to get it? Still downloading?
yeah.
About 20%.
All right, So this is the project on GitHub, and we're going to use the same folder to install a virtual env. So that means what I would do here is, you can see that I'm inside of this folder, and what I would do is I would just call virtual env. I'm using the no side packages option because I have an older version of virtual env. And the dot means the current directory, so I'm going to put this right into the tutorial folder. The effect of calling this command is that you should have a bin directory with a Python interpreter in it. And let's see if we can get all this tutorial downloaded in a timely way. What? It's not there yet? 4 hours? Or 4 hours? So once you have the virtual env set up, you should try and pip install Pyramid, which is the standard way of installing Pyramid and its dependencies. So the first step would be what? Get a checkout of the tutorial, then create the virtual env using this command that we just saw, this one. And then use the bin pip, which virtual env also creates in your bin. You won't have most of these, but there is bin pip, which you can use to install Pyramid. You don't need to activate before you, because you're saying explicitly bin pip. You're going to use the pip of this virtual environment. So you don't need to be more explicit than that. Let's see. Oh, really? GitHub is letting us down, right? So once you have the virtual env, please go ahead and do bin pip install Pyramid. So this is the step where we're actually going to install Pyramid and its dependencies. And you should see output similar to what I have here. So the first line is my terminal, where I say, so I'm inside the virtual env, which is why I have this bin directory, bin/pip install Pyramid. You should see output similar to this. And the last, the second last line is successfully installed, cleaning up, and then you know that it worked. This is also where we, by the way, see all the dependencies of Pyramid, right? Pyramid, Chameleon, Marco, WebOp, and so on and so forth. It's starting. Are you already at the pip install? Okay. So is there anyone not done with the... Oh, this is the tutorial? Okay. Yeah. Is there more people who are going to need a USB or something? Maybe I should put the tutorial up in another place also? Like a zip ball, some other location? If GitHub is what's slow, is that correct? It's working? So who's not done with downloading the tutorial material from GitHub yet? Is anyone still waiting for the download? Yes? Okay, maybe let's wait 2 or 3 minutes and then we can continue with everyone.
So what you wanted, if I understand correctly, is the directories x1, x2, etc.
Yes.
Together with the include and lib and bin directory in the same directory, right? Yes, okay, thanks.
Yes. So this is after the bin you only get after you have virtualenved. So as I said, the final stage at this point should be that you do bin pip install pyramid inside the tutorial directory. Anyone still needs more time for this step? I mean, it's more essential than the other steps. Because when you miss one of the examples, you're going to be able to switch to the next example folder and follow along again. But this one's kind of essential, because if you don't have pyramid, you can't run any of the examples. So I hope that everyone can install things. So you just arrived. In case you just arrived, again, I'm going to repeat for another time. You should get maybe the zip file from the top link and then unzip. Or, you know, if someone's not comfortable with these commands or the shell, or they still want to follow along, I'll suggest that you team up with someone. I'm sure everyone's happy to do the tutorial in pairs or so. So So does everyone want to continue, or do you still need some time, or you have it? It's working? No? Which command? Oh, okay. Oh, you're already with the first example? Okay. So if you already got the pyramid, that's cool at this point. Anyone doesn't have pyramid installed now? Maybe you? Okay. Right. So maybe we can go through the Hello Pi example already, and this is actually not something where you'll have to write anything, so you can just follow along while it might still be downloading for you. So if you want visit the x1 hello directory, there's 2 files in there. Each one of these steps has a readme txt, so you can, when you go home and you don't remember the details, the readme txt more or less contains the course of the tutorial and how I'm going to proceed. And if you want to complete this, or you can't complete all the steps, or you didn't understand some details, there's also links inside the README files, so you can go on, go further into the direction of the examples material. Some of the examples, or most of them actually, the steps, they're only going to touch the subjects, right? We're not going to be able to go into depth in any of these, but we're trying to give basically a good overview of Pyramid and where its strengths are, so that you can then, be hopefully inspired and then go home and read more or follow the links and so on. So the first example is the installation instructions are as follows. Actually, for those who haven't downloaded yet, this is not going to work, but so in your shell, once you have Pyramid installed, you can change into the X1. No, sorry, this doesn't need any installation. Forget about that. You can do I guess it's just Python x1 hello Pi, if I'm not mistaken. You should then get a message, server started at localhost 8080, and then you should be able to visit that URL in your browser. So this is just using the normal Python interpreter, but the one of your virtual env. So either you have your virtual env active and then you just type Python. The way I usually use this is I explicitly name the Python of the virtual env. So because I'm inside this directory with the virtual env, I can say bin Python, and then I just point it to the hello Pi file, which is our first Pyramid application. So if you want to switch to your browser, sure, okay. No, that doesn't work. All right. You're all way ahead, okay. All right, so let's look at so this is what you should get. And now we're going to look at the hello Pi file and see what it does, okay, how it's structured. I have lots of comments, but obviously these aren't required in your production code. This is just to explain what's going on. What we have here is actually polluting the whole thing. Hopefully you can ignore the red lines a little bit. From bottom, when I started this point, this is your usual if name equals main, and this is the code that's run when you point your Python interpreter at it. And what it's doing is there's a couple of lines, 1, 2, 3, 4, 5, and one more here that's concerned about configuring our Pyramid app. So the thing is, Pyramid has this concept of a configurator, which you use to configure different parts of your application. For example, you're going to say, you're going to use this config object to say these are my views, or say this is where my static files are, please serve them from here. Or you're going to say this is how I want to authenticate my users, or things like this will all touch the configurator, and the configurator is what then in the end, after we've done all our configuration, is used to create the WSGI app, which is at this line, and then we're just using the WSGI ref to serve our application. So this config object is essential. We're using it mostly, we're going to use it in startup code to configure our application, typically reading from a configuration file some things, and then setting up all our views. So this is, I think this is like the app object in Flask or so. So what are we doing here concretely? We have here we're instantiating it, of course. Here we're doing an add root, which is we're saying we wanna add a root with the name hello, and then we say this is the pattern that our root should use. The way it is, the pattern you can understand. There is a dynamic part in the pattern, which is the curly brackets name, and the first part is the static part. The trick being that name is, as you would expect maybe if you've worked with other web frameworks or roots, the name is what's passed to your, since it's interesting for your view, it's going to be passed to the view, and then you can ask for the name to find out what that value was. So basically this is how we are able to, in this example, in this view, we're able to read the bar. We're going to look at that in more detail in a second. A root always, these two come in pairs, a view and a root. So here we're saying we're adding a view, which is actually where our function comes in, where we render our HTML. This might be first a little bit confusing, but we need two statements here. What we're doing is we're connecting our root by name. So this is the one that we just configured up there. And we're saying we want to use this view, the hello_world view, with this root, right? So we need these two configurations to set up our view and make it available through the web. And what's a view? A view in this case is a function. So this, at this point I'm going to jump up to the hello world so that we can see how this thing looks like. And as you would expect, there is a function. It takes a request and it returns a response. This is a very minimal example that you should be able to understand easily. So the request object, as you would expect, has all the, say, query parameters. It has all the WSGI environment. It has something called matchDict, which is how we can access the name part, the dynamic part, which you can see here inside our view implementation. So the idea is that request has the query information in, we're going to see that later. There's request.params to get the query parameters. There is request.matchDict, which is the dict of, names that we have in our root definition mapped to values that were matched. So what you have here is saying hello name, and since this right-hand side request.matchDict is a dict, we can use it with the modulo operator, and then it's going to fill in the name into the into the hello string. So as you would expect, you can change the value of the name and it's going to get it from the request.matchDict. There is another view that we register further down. I would maybe let's go through this together and not read the text so much. I think maybe it's easier that way. But so now we have another pair of these add root and add view, and we're basically doing the same thing. Now we have a different pattern. It's called /JSON/name, and the name of the root as before. And here we have the add view as before, with the exception that we're passing another argument to this add view, which is renderer equals JSON. So Pyramid has this concept of a renderer where, as you've seen in the Hello World example, that we're directly from this is a web app response object that we're returning. But we may also, in our views, not return a response, but a dictionary. So that means this way we can uncouple the values that the view produces from whatever way it's going to be rendered or delivered back to the client. So that means that we can basically switch out, say, the templates, or we can switch out, the format. Is it going to be JSON? Is it going to be XML? Something. Simply by changing our configuration and not by, we don't need to touch the view code for that. So that's what the renderer is for, and it's what we're going to use further down. Sometimes it's just more convenient, and sometimes you'll just return a response anyway in your view in situations where, for example, you want to redirect to somewhere else. You're going to return a response that's called HTTP found. And that's still possible with views that have a renderer. So this is going to, in this case, if you return a response object, it's going to override the renderer. But if you're going to return a dict, it's going to use your renderer. And in this case, the renderer was called JSON. So what that means is that it's going to render your dict that you pass to the that you return from your view as a JSON response. You can see that I'm returning request.matchDict here, which is, as we discussed, the matchDict, which has available the keys and values from, from this root. So in this matchDict, we expect, if we say hello /world, we expect the matchDict to have to map name to world. Sorry, and this is what you're going to see if you go to the hello JSON. So what I would like you to do now is open up the page and try out this this root here and see what you get back. Instead of hello, we're going to type JSON and then maybe EuroPython, and this is a JSON response, right? And this is exactly the matchDict. When you look into the response, you can see that it has the correct content type set and everything for you. So this way we don't need to have a JSON dump in our view. We can be more dynamic. We can be more flexible. Our view could be, serving different clients or something. You get the idea. Right? So this stuff down here isn't terribly interesting. This is using the standard library WhiskeyRef to serve the app, but normally in bigger applications you would use typically paste deploy, and we're going to use that in the following examples. So is that, do you guys have that example working? Okay, great. So this is where we're getting some logging from Whiskey Ref. All right. So let's switch into the second example. What you're gonna see here is this is a complete a Python distribution. So the second example is already like packaged up nicely so that you could, for example, upload it to your server and do deploy it nicely and you know, upload it to the G shop maybe or something. So this is the product of running using pyramid scaffolds to create a starter code for your project. So the idea being that when you start a new project, you don't want to write every bit of the code, the bootstrapping code. It's done for you. There's a couple of different profiles to start with, okay? So Pyramid itself in the core has back here at the prompt, at the shell, I can say bin, what was it, pcreate? Right. Let me see. So this is the templates that Pyramid comes with. There is I guess a neutral Pyramid starter project. There is one scaffold called Alchemy and one scaffold called CODB. And these are two flavors basically to start your project with or to use Pyramid with. The Alchemy one, yeah, just as it says, it's using SQL Alchemy for persistence and it's using URL dispatch. URL dispatch is what we've seen in the previous example. This add view and add route, I mean the routing is called dispatch in Pyramid. And the CODB scaffold is the one that we're going to use to build our application. And it uses something, I mean it uses the CODB for persistence, which is an object database that we're going to look at in a minute. And it uses something called Traversal, which is another concept of Pyramid, and which is, in my opinion, one of the big strengths of Pyramid. So this is what I want to show you, because this is a feature that really is different to other web applications, maybe, frameworks, I mean. So what we do, the command to create a new project with Pyramid is, and please don't actually run the command because, you know, or you can run the command with a random name, you know. So what I did was I ran this command. I'm using the ZODB template to quickly start my project, and then it creates a folder for me, and you know, it's going to put a lot of files that I would otherwise have to copy from another project, maybe that I've worked with, or have to write my own. So this is what I did in the X2 folder, and this is what the X2 folder contains now. It is actually all the files that are contained in the scaffold. So there's been no custom code in the second step. The second step being the X2 folder, right? So let's have a look at the X2 folder. And we're going to see what it contains as files, and then move on from there. So as I said, Pyramid has a few persistence options. One is SQL Alchemy, as you saw, ZODB, but there is also available in the Pyramid cookbook on the Pyramid website. You can find examples on how to hook up CouchDB or MongoDB with Pyramid, and it's all really simple because it was built with this kind of pluggability in mind. The ZODB is what we're going to look at as for persistence. It's from its website. The ZODB is a native object database that stores your objects while allowing you to work with any paradigms that can be expressed in Python. the big advantage of working with ZODB, in my opinion, is that there is no gap between the database and the program. There is no glue code to write, no mappings to configure, right? So as you would usually have some kind of ORM object or some way to glue together your database and your Python application, with the ZODB there is native support for Python objects. Basically this is implemented using the pickling, the Python pickling, and so that means that you will have, you know, it's almost 100% pure Python classes that you're going to use to, and no strings attached, basically, to store your application objects, your model objects. So this is the I don't know how much you know about Python distributions, but you know, if you know about this, this is not going to be very exciting for you. We have a setup.py file. That setup.py file will list the dependencies. Again, this is already done by the scaffold. I haven't done any changes to this. And we can use the setup.py file to install into our virtual environment this X2 project. So what we're going to do is for each project, we're going to need to set it up to be able to run it, okay? So what does that mean? That means that you will have to change directory into the X2 folder. So this is where you will have the setup.py file. And then you'll need to run with your, I mean, again, either you already activated your Python or you will need to point to the Python interpreter inside your virtual env. So in my case, it's actually important that you cd into the directory, otherwise setup.py is going to fail. So you need to, from this directory, in my case, I need to go up. So if you're not using activate, you need to use /bin Python to point to the virtual env's Python, and then do setup.py develop, which is the command that we're going to use to install this example into our virtual environment so that we can run it. And once you run this, for me it's going to be quicker than for you, because you're going to install these additional dependencies that Pyramid core doesn't depend on, right? But notice that we have things like Pyramid debug toolbar or ZODB con, which is a convenience for using the ZODB, and the ZODB package itself. And this is going to be downloaded and hopefully compiled and ready for you. So once you've run this, you should get something, some output similar to this, and more concretely, you should be able to, using your interpreter, you should be able to import the packages. Let's say we're going to try and what do we have? We just, I guess we installed, is it? Right. This is imports ZODB you should be able to do now in your virtual environment and not get an import error. Right. Is that working or still downloading or downloading? All right. So while we're downloading this, and we're going to be able to use this virtual environment in the next few examples, so we're not going to need to download this one again. So that's nice. But while we do this, while we're waiting, let's look a little bit more at this structure of what Pyramid set up for us. So this changes file is just, you know, your change log. The two ini files here, development and production, they are two configurations files for your Pyramid application. And as they suggest, one is for more appropriate for a development environment where you have debugging tools installed. One is more appropriate for production environment where you're not going to use debugging tools that are potentially insecure. So looking at the development ini, what we see here is the most interesting section is the app main section, which is this is paste deploy. I don't know. Have you worked with paste deploy, the configuration files like this before? So basically, there is a command called pserve. It used to be paster serve, but now it's called pserve because of there's been new software to replace the old one, basically. And what pserve does is it reads this file, and this is where it finds out how to import your application and how to run it and how to configure it. And so we have a couple of development related settings here, reload templates, debug authorization. This is stuff that you don't want to put on in production, but you want to see in development. There's a couple of debug flags here. The pyramid includes is interesting because this is where we connect from different applications. So these are basically like the blueprints in Flask, if you know these. What we're doing here is we're depending on pyramid debug toolbar, say in our setup py, but we still need to activate it in our application, right? So that's two different things. One is installing a package into your environment or into your system. The other is activating so that it has actually any effect on your application, right? So this is the pyramid includes. We have 3 packages that we want to include so that they can do their job and help us build our application. And once if you're using different modules or different extensions, this is also where you need to put them to be able to use them. Is it slow or?
With the mock package, it seems.
Start again. No. I started 3 times and I'm ready.
Okay, so the mock, huh? Let's see.
I get 503 service unavailable. We are bashing him, maybe.
Yeah. Okay.
So with mock, you might be able to just point him at.
Maybe he has a limit on the concurrent connection. I don't know. Yeah, downloading.
So here you can also say, using again the pip of your virtual environment, you might be able to say something like directly point it at the. I copied this link from the PyP site here.
Yeah, the alpha version is trying to download.
Right, so it's probably trying to follow this link here. Could be?
Yeah, that one.
Right, so what we can do is we can explicitly state that we're not interested in that version. Let's do this maybe by copying this link and pointing pip directly at that version. So what I do is I say pip install and then this guy. And this is going to not look at the web page and not follow any broken links. Sorry?
You don't have to point it directly. It does the right thing.
Okay. He's saying we don't need to explicitly, with pip install, it's going to do the right thing just pip install mock.
Right. But the problem is pip install mock is going to look, I thought the problem was that he got confused because he was following this link, right? Normally you would just say pip install pyramid like we did before. In this case, we're pointing to the download link directly because pip gets confused because it follows a broken link, apparently. I think this is what's happening. Yeah, right, this link, right? So pip is trying to follow this link and then it breaks. So what we do is we give an explicit URL. We just take the release from down there and ignore everything else. Like you can copy the link to this file and then just pip install this URL.
Yeah.
Like this, 080.
But maybe try to do
We didn't use the Pip.
Development.
Just point him at the URL, okay? Because he's not going to be able to otherwise figure out. He's going to visit that page, and maybe he's going to crawl even the broken link, even if you give him the. So if you have this problem, just just point him at this one, and it's going to hopefully just work, like it did for me just now. Look, this is pretty quick.
Yeah, it seems the Python setup.py developer is trying to download the newest version, the mock newest version,
right,
while Pip install is installing the 0.8, this one.
Is it that way?
Yep.
Yes, I think 5 minutes ago.
All right. Okay. Sorry, didn't get that. All right. So, where were we? So what we have here is two more configuration options, and these are actually CODB specific. The one is saying the number of transaction retry attempts, because CODB has this thing where it may run into conflicts with other requests. So your request might try to write the same object as another one at the same time. So this is what CODB does in this case. It's just going to retry. And this is your connection URI. So this is how you're going to connect to your database. In the case of SQL Alchemy, this is SQL Alchemy URL or URI, I don't know. And then, so once we have this guy installed in X2, we can go ahead and use the pserve command and the development ini file. This is a line break right there. It should be one line, I mean. Use the bin pserve to run development ini, and it's going to start up your server, and then you should be able to visit that address. Now note that it changed. Before it used to be 8080, now it's 6543. Okay. This is what you should see, yes? It's complaining that what? What about the installation? Did you get a success message, or did you get error messages? Maybe the compilation of ZODB failed, because if you don't have the Python dev maybe headers, then it's going to fail. Or you don't have a C compiler installed, then it's going to fail. Right? Did you spot the error? And build essential, there is a package that installs the C compiler. Okay? Alright, so visit that page and you're going to see this, the scaffold.
Just before you passed on the command line.
This one?
Oh, yes.
So this is just a continuation character here.
Okay.
And it continues there. So this is one line. Just bin pserve space development ini. And in a similar fashion, of course, you could use production ini to use your other profile. So this is what we get from the scaffold, and let's have take a closer look at how this works. We have our project divided into static, there is a static directory that has all the static resources, you know, like the icons and CSS. There is a directory that has all the templates for our project. This is how you would maybe normally divide your project into different parts. There is templates, there is models, and there is views, and then there is tests. What we're going to look at first, I think, is maybe the init, which has the entry point into our WSGI. So this is basically boilerplate that is going to, you know, use the configurator again, but this time using a settings file, the one that we provided, the development ini. So the settings that are passed here to the dev main, they are coming straight out of the file, and they're going to be available to us using, you know, something like request registry settings later on. So in your application, you can always access these. The other thing that we do is we add static view, which is how we are then able to serve these static files that you just saw. So we have a static directory, and we're registering it as the static. So the name is the same as the directory. Therefore, we can access our static resources like so, right? So if you're going to try and open this URL, you can see that this is actually mapping to the files that we have in the static directory. We're using one thing that's called the root factory here. That'll need some explanation. When we create the configurator, we're passing the root factory. This is kind of important for Traversal, which I'm going to talk about in a second. Actually, let's talk about it now. Traversal is this thing that one of the things that makes Pyramid special, and it works like this. Traversal starts at the root, and it will map the URLs. Where do we have it? Sorry, here. So what it does is it basically works like a file system where you have a root in your file system, and then basically the URLs are mapping into that file system. So if you have /about you know, /index.html, then it's going to kind of go into that graph of objects that you have, and then try to find that object. So the idea being that, you know, here you can see a very simplified implementation of Traversal. So we have a def traverse with a path and an object, and the object would be maybe the root object of our application. So that's what the root factory is for, right? Its responsibility is to provide a root object for our application. There might be also different root objects depending on how you work. And then given this root object and the path, it's going to maybe split the path into segments and then use dict access to traverse from one object to the other. So this is the essential line. These traversable objects, they all have under, get item, under, and they will be able to, like dictionaries, right? They will be able to provide you with the next child object. So here is an example down here where we say the root is this dict. So this is a dict nested, 3 levels. We have the root is the outer dict, then we have files, which is pointing to another dict, then we have accounting, which is pointing to another dict, and so on. And down here you can see how I can then traverse using my function at the top here, traverse using the root object that I pass as obj, and this path. This is pretty easy stuff, right? But it turns out that it's very powerful for some web applications. So it's really similar to how a file system works, and it's nicely mapping the the path segments to objects in your graph. in your object tree, I mean. So this is what the root factory does. Let's take a quick look what the scaffold did for us there. Here in the init, this root factory is calling another function that's in our models until the break, right? Thanks. In our own models module, and the app maker is, as you can see here, its responsibility is actually to return the root, and it takes the CODB connection. You don't actually need to understand all of this, but the way it works is you get this connection. The development ini, remember, it had this connection string, so this is how we figure out where to connect our database, how to connect it, and then we can call the app maker to return kind of our root object. And let's take a closer look at this app maker. What is it doing? In our models py file, if you want to open that or just follow along here, there is the app maker, which takes now it's SODB root, which is the database root that we connected to. So SODB also works with a root object, and basically, so this is an object where you can attach to. It's a dictionary-like, and you'll be able to attach to it other objects, and these objects are then persisted inside your SODB database. So the way this persistence works is, as soon as your objects have a connection in the graph to your ZODB root, they're going to be persisted, right? This is basically all you have to know about ZODB persistence for now. And what we're doing in this app maker is we're saying that if not app root in ZODB root, basically this object here is still missing, it's not there. We're going to create a root, we're going to put it into our ZODB, and then we're going to commit the transaction and return that root object. So what we return here in the end is an instance of my model, and it depends on, say, if you already started this application once or not. Depending on this, it's going to give you a root object that's what? That was already retrieved from the database, or it's going to create a new root object if we're working with a database that doesn't have this root object yet. So our application root. Right, so hopefully this makes sense. And what we have up there is our myModel class, which is this guy here, right? So what we're doing is we're inheriting from a class called persistent mapping, and this is coming out of the ZODB, and this persistent mapping is basically a dictionary. That's all you need to know about it. Why do we at all inherit from a class? Inherit from a persistent class? It is because if we wouldn't do it at this, I mean, there's persistent classes, and they will mutables. When you change them, the ZODB needs to be otherwise notified that you changed the mutable object. With this persistent classes, when you derive from them, it's going to be more convenient to work with them because you don't have to set the dirty flag basically when you want this your changes to be saved. Otherwise, ZODB would have no idea that you actually changed your objects, and that it would have to write them out again. And so this is just a normal Python class, as we said, ZODB, and then we also have here under parent, under and under name, under attribute, which is two attributes that we're going to look at soon. This is part of the iLocation interface, and we're going to see. I think I'll have to actually speed up a little. I'm a bit behind. So for some it's going to be too slow, for some it's going to be too fast, right? But that's how it is. Right, so this is, and then we switch to the views, okay? And so here we're actually using, this time, remember from the last Hello Pi example, we were using config add view. This is an alternative way to register your views. It's using a decorator, and you might find this more convenient, but it's just doing the equivalent thing. Actually, not exactly, but still. And this view configuration, remember the last one, it was using a root, but this one's using traversal, right? When you use traversal with this path segment traversal thing, then you'll have to register your view a little different. There is also only a view config now, which is equivalent to config add view and no config add root anymore. So this is not necessary for when you use traversal. We only need one decorator or one function call in this case. And what we do here is we pass again a renderer, and this time it's interesting because we're passing a renderer that's pointing to a template. So this way Pyramid knows it should use this template to render this view. Okay. In this template, again, just like with the JSON example, we will have available the dictionary that the view returns. So the view returns a dictionary, the template gets that dictionary. It may use the values of that dictionary to fill in portions of the dynamic portions of the page. Here, we're registering this view for a context, and that's pretty important because what this does is it tells us if Pyramid goes through our application and it finds an object that matches the URL, say in our example, where was this? The README, was it? No. Sorry. Right, so imagine that it traverses to a given object, and this might be a my model object or any other model that you have, and then it says, okay, now that I have found a my model object, how do I find the view to present this object to the, say, user, to the browser, or how do I, which view to use is the question, and the answer is he's going to use the one that has the right context configuration here, right? So the idea being that if we find a my model, we're going to use this view to present the model object. And the my view takes two arguments this time. Notice that the last one took one argument. This is taking two arguments, context and request. Request is what we already know about. Context is an instance of my model. So there's no need to go and fetch from the database that object like you would maybe do in other frameworks. Here you already get the object that was traversed to. By the way, this is also accessible at the request. There is also request.context, and these are equivalent.
I'm a little bit surprised that the template itself is the renderer.
Right. Yeah, that's funny because before we had JSON, and it's kind of a type of renderer or something, and this is a concrete page template, but it works this way. So I think it's by the suffix that it knows what kind of renderer it is, and then it's using that to make a template renderer with that name or so. So that's just maybe a convenient way of spelling this. Right, and so notice that our view, it returns a dictionary, right? And it's a static. We're not using any variables here, but still, project is pointing, the value is x2, so basically the name of our project. And this is what's used in the template to replace a value. So let's look at the templates file, my template pt. This is what, again, what Pyramid already created in a scaffold for us. And it's, you can see that here we're replacing the value, the project, right? This is what the view returns. And so this is called chameleon page templates. You can use the familiar dollar curly braces syntax, and we're going to look at more syntax later in the later examples. Just so you know, this is Chameleon. It's the name of this templating stuff. But again, you can use whatever you want, right? There's examples. There is even a scaffold, I think, that you can use to have Marco templates or Jinja or whatever you want, whatever you prefer. So everyone was able to start the second example and see the page. So now we can move on to the third one. Let me just actually, to illustrate the traversal a little bit more, let us go back to our shell in the X2 for just another moment before we complete this this step. Let us call this command called .bin pshell, and then point it to the development ini. This is the command that I just put in. So there's in your virtual env spin directory, there's a pshell command, and the pshell takes the same argument as the pserve before. It takes a configuration file of your application, and then it gives you a Python shell that's quite convenient to find out. I mean, you can introspect with it your application and your database. So what's happening here? We have a couple of variables already there in our environment. Specifically, we have the root. So if you type root, you're going to see an empty dictionary. This is the root object that we created. This is a my model object, right? It's just a representation of an empty dict. So my model is the root as we created it in the app maker function. And so as I said, this is a dict, right? And let's say we want to let me do an import from X2. What is it? Models import my model, and then we're going to write Python code to add to our root a folder. Okay, we're going to call it my folder. I'm going to say here we're going to put a my model and put it inside our root object. And the other two calls that we need to do is we need to from transaction import commit and commit the transaction so that it's written out to disk. Okay. So if you try these things, these lines in your own pshell, then you should be able to traverse to that my folder object in your app. So before you were opening the slash, now you should be able to open slash my folder and not get a 404. So I can I would have to get out of the shell again because I just quit my server, and then start the server again, and then you're gonna be able to hopefully say a slash my folder and then find your object. Although it looks exactly the same as the root object, but you can feel that it's there. Does that work? Yeah. I don't. Is it possible to use IPython? I don't know. I guess for now you'd have to cope with dir and all the old school stuff. I'm pretty sure it's possible in some way or another, but I don't know it. Sorry. All right. So I'd like to start with the first example. I mean, the one that we code ourselves, maybe before the break, and then we're gonna have the coffee break at 10:30, and then we're going to come back. So people who are very eager, they can do a little bit in the break. So this is us going into the third example. This is what I just typed in. You can also find it in the readme.txt inside the X2. But so now I'm switching over to the X3. This is the templates. So we're, just like with the previous example, we'll need to run bin python setup py develop, right, like this, just like before, to set up, to make this application available inside our virtual environment. This time all our requirements are already satisfied, hopefully, so there's no need to download anything. And then when you start this application, you're going to see a 404 not found page, okay? So that's, how do I start this? Bin pserve to serve the application. Was that too fast, or you just heard yourself? All right. So now, when you go to the application, you should, when you open this up, you should see this guy. This time it's not my mistake. And then, when you've seen this with the pserve, go into the X3 templates directory. We're actually having, you notice that each one of our examples has a double nesting. This is because we have the setup py in the parent folder, and then the actual code in the folder below. Here, when you go into the models, you can see how I already for you replaced our my model with folder model, which is actually also because, you know, mappings. This is how we use the traversal. So you're going to use a dict mapping. In this case, it's the same as the dict. And so what I did here is I made an init where I can set the folder title and the description. We want to be able to add folders to our application here that have titles and descriptions, obviously. The set item, and this is where the under name and under parent attributes come in. This is stuff that allows Pyramid to find the location of any given object inside the graph, right? So by providing to Pyramid the parent and the name being the segment in the URL path, right? So imagine you have a folder that's called, like we just edited my folder, then that my folder instances under name is going to be the segment in the URL path, and it's going to be the key that you use to get it from its parent object. So in that case, we would say maybe root square brackets and then my folder. That my folder is going to be the name, and the parent is going to be the self in that case. So I'm providing a set item in our folder model that sets these attributes for us, so that we don't have to worry about this. Every time that we put an item into this folder, automatically we'll set the reference to the parent and the name and so forth. This is actually a pretty cool feature of the SODB. You can see that there was no need to set up anything. We can just refer from one object to another, and we can have cross relationships and references between objects, and it's all not a problem. So no need to set up any relations or whatever. And this time around, I'm using the folder in my app maker. So I replaced code that would create the my model object as the root, and I'm creating one of these folder objects to be my application root, right? So when you go to slash this time, there is no my model anymore, but there is one instance of the folder that you saw. And here is how you create it. I mean, just like a normal Python class. And then here is how you connect it with the ZODB. So this is going to be our app root. This transaction commit, we have seen it a couple of times now. it's rarely needed in your own code. It's needed in a P shell, and it's needed basically in this code. But other times it's not needed. That's because a pyramid has a transaction manager. It's managing the transaction for you. So when the request starts, it's going to begin a transaction. When the request finished successfully, it's going to commit your transaction. And if your request, if in the process of in your view or wherever, there is an exception, it's going to roll back or abort that transaction. So there's no need to usually worry about this. Just noticing, because we've seen it a couple of times, but in your views, you can change your objects, you can do whatever you want without the need to write this code. Actually, it's an error to write this code, because if you would write this and later in your request cycle, in your response, you would get an exception, then you would have an inconsistent state because you committed parts of your things, and then maybe later there was an exception, so you have a bad database state maybe. And so what I'd like you to do now is to start up this application like I did, and notice that you get a 404. And then I'd like you to go into the views py and just make write a view that so that we can actually look at our folder. And that view should just return actually an empty dict. So the only thing that's interesting at this point is the view config. We need to adapt the view config somehow for our folder, and then we'll need to. I think the idea is also to put into the templates. What is it? Now this is already there. So the templates is already there. You just need to complete the views code to add one of these views. The correct configuration is what's most interesting here. You can just return an empty dict, and then you should be able to see that folder in your page without a 404 error. So if you want to do that quickly, maybe 3 minutes should be enough for you to complete this one. Once you actually see the page and things are working, you might want to, you can try out the P shell, or actually let's finish up together, and then we're gonna look at the next features. Time to get up. Sorry? The renderer should be, oh yeah, you're right, there is a templates folder PT. You should use this one. It's up here.
What should be the name of our view?
There is no name. As with the previous example, when you say no name, it means that, actually let me talk about this in a second, but the default view has no name, and only if you add something at the end in the UL path, say you add another segment that says edit or add or something, then you're gonna need a name. But if you only point to the oh, the name, okay, yeah. Well, that doesn't matter. The name of the function doesn't matter. No. It's only through the view config decorator that he connects things. So there's no implicit meaning of the function name. Right, so once, maybe I leave another minute. Is there an issue I can help? Or? So it's already turning out that we're probably not going to be able to make all the examples, but then maybe you can finish on your own after this tutorial if you're then still interested in Pyramid. Okay, so another minute maybe to complete. After this, you need to restart your server, and then to see the changes, right, you need to Control-C. What you return in this view, you should return an empty dict for the moment, because we're not actually returning any values for the template. The thing is, the template has access to the context, so it can directly get from the context. Is there someone who is running already? All right. Right, yeah. I set up some templates. I switched to Twitter Bootstrap for this example. So that's just a matter of switching the static files and stuff. You can see in static there is now jQuery, Bootstrap, and I'm using these this time around. There is an interesting thing about the templates now. We have now two templates. We have a master and a folder template. Like you would expect, the master has all the the surroundings. It's the O template or whatever you call it, or the master template, and the folder only has the things that concern the folder object. So we have separated our styles and our layout into two templates here. And the way this works is using something called metal, and you only need to remember for now, or just look at them. Let's look at the folder PT first. The folder PT is quite simple because it basically delegates most of the hard work to the master. So what we do here is we say metal use macro, and it's going to use the master PT as the macro. And then we say fill slot content, which basically corresponds to a slot that we defined in the master. So the master has a place where it says define slot, and this is where this stuff is going to get filled in. So it's relatively simple, although the syntax will maybe need a bit of exercise for you to remember. Use macro, define macro, fill slot. But most of the time you don't really, you could just copy this or... So I'm just going to complete the example so that everyone... right, we still got 2 minutes before the break. So that would be, that would be from models import. Can we maybe stretch out 2 more minutes?
Yeah, sure.
Excellent.
Sure.
From models import, what was it, folder, right? And then we're going to use code similar to this, except that what we are not returning anything. An empty dictionary. And we're going to use folder as the context, and we're going to use the folder PT, and that should work, I guess. Alright, so I've only done minor modifications, and now I should get this one. And this is basically the start of the application that we're going to write. And let me just quickly, before the break, look at this one. Sorry if you don't get any cookies anymore because they're all gone. But the context, so the context is a context object as you would expect. You have direct access in the template to that. So there's no need to return all the values from the context also in the dictionary, because context is always there. So we can say context title and description. And what I have here down there is I have a repeat, a tile repeat, which is my my template's way of repeating over items. Okay, so take a look at this construct and try to see what it does. The values is coming from the dict, right? Because we can iterate over the dict's values here. So this is the syntax, item, context values. So this basically translates to 4 item in context values, and it's going to render 1 link per item. And user request resource URL. This is a way to render for an iLocatable. So this is why we need the name and the parent. For an iLocatable, I can render a URL. And down there, I'm going to say item title. So this whole part here is concerned about giving the child objects and providing a link to the child object so that you can click the link and go into the child object, basically get the view for that folder. So with this, you could already experiment and use the P shell to make maybe a folder structure, or use the, you know, the app maker to make a folder structure, and then you can see if you can find this one. For those of you who maybe return earlier from the coffee break, you might want to. There is a breadcrumbs up here, but it's broken, right? You might be able to fix the breadcrumbs looking at the code that we used here in the tile repeat to do maybe something similar. Remember the under parent, or try to find more hints in the readme.txt if you want to continue on this one. You should be able to do what? To be able to build a working breadcrumbs, and maybe you can use the P shell to add more objects into your graph so that you can actually click around and see the list in action and so on and so forth. I guess with that we can go into the break. Thanks.
Do you think we'll meet again in? We start at the regular time. Do you want to start earlier? Later?
Yeah, I would like to. Okay. What would that be?
It would be 11:15.
Okay.
Is it okay?
Yes.
Okay, so I'll see you at 11:15. Thank you.